system is clean for best this thing. Antivirus and all you can keep, but apart from that, please disable for best this thing. Perfect. So let's wait for others also to join in, and for Shrikant sir also to join in. Obviously, we cannot start without him. The session is all about him. Sandeep, hi. Hi, everyone. Can someone write something on the chat as well so that I know chat is open for everyone? Is it? Hi, hello. I think Shumunathan, it must be for you. Hi, hello, good evening. My voice is clear, no? Is there something from background that you're hearing, some audio? Hi, hello, good evening. Hi, Vishal. Very clear. Thanks, Sagar. Thank you, Ayush, Aniket. Thank you, Abdullah. Hi, Satyam. Hello. Hello. Hi, good evening. Perfect. Namaste, Shivam Saxena. Hello, good evening. Perfect. So before we move in, I'm seeing still people are joining in. Very quickly, walk you through the platform. Must have been through our different events as well. This is Drona. Please use the chat window to communicate with me. Use the questions tab to post questions for Verma sir and for me. So I will help, associate questions to sir. Why so? Because only one of us can be on the screen at time. Hence, it is very important that you paste your questions on the questions tab, because the chat window is an infinite scroll. Now, just quick introduction about me. I am Mihil Dikshit. I'm here in the marketing and product team here at Scalar. Part of my responsibility is also to ensure that I walk you through what are the current happenings in the data science industry and how we can help you. So primarily this session will be on the lines of what you should be saying during interviews, how to target better roles and better companies, what are the salaries and CTCs you can expect in such roles, what should your profile look like, what should your resume, CV look like, what all are the live projects that you must do, some experience that Shrikant sir that can share with you, what can your career graph look like, and obviously some other questions that you will be also sharing. So this will be a very, very small session. Hence, I would request you to post your question on the questions tab. Yes, Rahul, I can see. But next time, would request everyone to start posting it on the questions tab. I see some questions on the chats tab as well, might get missed. So a very humble warning and this thing to everyone. If you would want your questions to be addressed. Hello, Harish. Perfect, Ajay, do not worry. Now, as far as the gate keeping are associated, do not worry if you're from any other domain or if you're from non-tech. As long as you have an undergrad degree from a certified UGC institute, feel free to attend the entire session. It's perfectly all right. You can make a mark for yourself in the industry and it's open for you. So there are no barriers as such. Is everyone aligned with me? Can I get a yes before we move in? Perfect. A lot of questions about how Scalar is different and good questions, but we'll address them as and when. Hence, for now, let's just ensure that we're all on the same page. Everything's working fine. Thank you. Thank you, everyone. Thank you for a kind response. I see Shrikant sir has also joined in. Sir, without any further ado, over to you, please.
A big thanks to my co-host, and let's get started. Folks, today's session is all about data science and machine learning, and we'll understand what all roles are available, what are the core skills that you have to know, how to build a career in data science, and how to get into data science. And given your current background, how do you transition to data science careers? Again, I will cover all of that. But before we go there, I just want you to confirm. Again, I have a two-screen setup. I just want to make sure everything is clear. So can you please confirm if you can see my screen, if you can hear my voice, if you can see me? Again, please go to the chat window and say thumbs up if you can see and hear me. Okay, cool. Looks like everything is working as expected. So let's get going. Just a second before we go there. Okay, cool. Since we know the agenda of today's discussion, of course, I'll get into the detailed agenda in just a while. But first and foremost, a brief, quick introduction. So let me just get going there. My name is Srikant Verma Chekuri. I'm one of the instructors here at Scalar, and I've been at Scalar for over a year now, and I've been primarily responsible for designing the curriculum and helping our learners transition to data science careers. Prior to this, I was a co-founder of a startup called Applied AI and Applied Roots, where I've been fortunate, along with my co-founders, to have helped tens of thousands of learners transition and learn data science and foundations of computer science. Prior to that, I was working as a machine learning scientist, a senior machine learning scientist and lead for Amazon, both out of their Silicon Valley office in Palo Alto, as well as in their Bengaluru office. So I started off my career in Bengaluru and then moved to Silicon Valley to build a small team of scientists and engineers. Prior to that, I was also a founder of a computer vision startup, which was building some very interesting, cool stuff. And earlier to that, I worked at Yahoo Research as a research engineer, which is sort of like a machine learning engineer. What we call machine learning engineer now used to be called as research engineers. And earlier to that, I was at Indian Institute of Science, which is where I learned a lot of foundational machine learning and computer vision and some of these techniques. And again, just to connect the dots, and very importantly, I studied in probably one of the smallest engineering colleges. I know this because I was the first batch of my engineering college. I studied in engineering college called Sanketa Vidya Parishad in Visakhapatnam. I was the first batch, so I can proudly say I joined one of the youngest engineering colleges in the world. But my journey has been terrific. I've had ups and downs. I've had a lot of learnings. And whatever curriculum we've designed at Scalar, we've designed keeping learners from all backgrounds. I'll walk you through that in a short while. Again, you can find more about some of the startups, some of the work that I've done in the past on my LinkedIn profile as usual. Okay, now what's the agenda for today? Okay, so let's get going. Again, I'll keep looking at the chat window just to understand what's happening. So whenever I look down, I'm literally looking at what chat is happening here. Cool. So let's get into the agenda. As far as the agenda is concerned, first we'll start with data science and machine learning roles and what salaries you can expect, especially if you're first getting into data science and machine learning roles, right? So first and foremost, let's understand what all roles are available, what are the typical salaries, so that you have a realistic estimate of how much you might make as a data scientist. Again, this is a very common question that we get asked, so we thought we'll clarify it at the very beginning. Next, I will talk about, this is probably more important, which is all about what are the core skills that you should have for a career transition into data science. Of course, there are multiple data science and machine learning jobs. Each of them have a slightly different skill set that is needed. Then I'll walk you through a detailed roadmap on how to become a data analyst or a data scientist. These are the two most common data science roles. Of course, there are other data science roles also that I'll talk about. Next, I'll give a brief overview of the Scalar's data science and machine learning program, where I explain how we designed this program, and this will also help you understand how you can learn data science appropriately so that your career transitions are sped up. Next, I'll also give you a few resources to get started in this journey of data science career transition. I'll also spend some time answering Q&A. Again, I also have a co-host who will help me throughout this session, who will handle some questions, who will also help all of us in this broader session. Cool. Again, I request my co-host to collect some of the questions that participants are asking so that we can collate all of them and I can take some of them at the very end. Cool. Now, the next question that many learners or participants have is, for whom is this session? Okay. Again, I hope the agenda is very, very clear. Can you just say thumbs up, thumbs down? Is the agenda clear? Let me just go one page back. Is the agenda very clear on what we are trying to get done, what we are trying to cover in the next few minutes or few tens of minutes? Okay, cool. Okay, so for whom is this session most appropriate? Okay, so let's go there. Anybody who wants to transition to a data science career, anyone from any background, right? For example, anybody who wants to get into a data science role. Again, there are multiple data science roles that I'll cover briefly in a while, but you could be a fresher, right? You could be somebody who's coming from a non-tech background. You could be coming from a tech background, like a software development engineer or a front-end developer, right? Like a front-end developer, right? You could be coming from a tech domain. You could be coming from other engineering domains, not necessarily software and tech, but could be mechanical engineering, civil engineering, etc., electrical engineering, etc. Or you could be somebody who is already in a data science role. like a data analyst or a data scientist who want to upskill and get into better types of roles. If you're any of these, if your persona fits any of these backgrounds, right, and if you're planning to get into data science role, this session is very, very appropriate for you. Again, I'm sure that would have become clear by just looking at the agenda, but I just wanted to call it out on for whom is this session most appropriate for. Okay, now let's get into the crux of it. This is what I've been telling for a while, which is first let's understand what all data science and machine learning roles exist. Okay, so the easiest and probably the fastest role that you can get into is typically referred to as a data analyst. Right, so I'll explain what skills are needed for each of them, etc. Again, some companies might also refer to data analysts as, let's say, some companies call them as risk analysts, especially in the banking and financial domain. Data analysts are also called risk analysts. In product-based companies like Amazon's, Google's, startups, they're also sometimes referred to as product analysts. Right? Again, there could be different names. They're also supply chain analysts. Right? Similarly, some of the older companies also might refer to them as business analysts. So essentially, an analyst's job, again, I'll give a brief of what the job entails. If you're a data analyst or a risk analyst or a product analyst or a supply chain analyst or a business analyst, your job is to take raw data, which the company already has, or some external data, and come up with insights from the data. Come up with insights, come up with intuition, understand what's happening in the real world through data, so that businesses or your leadership or your managers can make the appropriate decisions. So your fundamental job as a data analyst is to gather insights. Again, to get insights, there are a bunch of statistical techniques, there are a bunch of coding related techniques. Again, there are some software engineering concepts. I'll come to that in a little while. There are some tools also through which you can get insights, like Tableau, Power BI, etc. But I'll come to that briefly. But your job is to get insights from raw data. It's as simple as that. The next role is typically referred to as a data scientist. Right? So a data scientist is someone. Okay, let me also give you what a data scientist typically does. A data scientist should be able to do everything that a data analyst does. Right? So plus, I'm putting a plus symbol to say everything that a data analyst does, plus they should be able to build machine learning and deep learning models. Again, now what is a model? A model is basically a mathematical system which can make sense out of things. For example, let me give you a simple example. There is a machine learning model that is recommending videos for you when you go to YouTube. On YouTube, let's say you're watching a video. For example, you're watching a video on YouTube. On the side panel, you get similar videos that it's recommending. That is driven by a machine learning model, right? So a lot of a data scientist's job is to be able to gather insights, but also gather insights just like a data analyst does, but also be able to build machine learning and deep learning models. Plus, they should have basic software engineering skills to deploy these models. When I say deploy these models, they should be able to put it in front of a customer through a piece of software. Right? I'll come to, again, there are a bunch of skills there, which I'll come to in a little while. That's a data scientist for you. Next, the third type of role is typically referred to as a machine learning engineer. Again, there are different names for a machine learning engineer. Some companies might call this as a research engineer. Some companies call as computer vision engineer or a deep learning engineer or a data science engineer. It's basically the same thing. A machine learning engineer is somebody who is half data. It's a combination of a data scientist plus a software engineer. So typically people who come from software engineering backgrounds who already can write production quality code, real world code that you can deploy and productionize. So a machine learning engineer is typically a combination of data scientist and software engineer. This is, again, I'll tell for whom is it most appropriate for. As you can guess, it's if you're coming from a computer science background or if you're already a software engineer, a machine learning engineer is the most appropriate role for you. The fourth type of role is typically referred to as an applied scientist. Again, these roles exist only in a handful of companies. Typically, your FANG companies, top product-based companies may have an applied scientist role. Again, an applied scientist is somebody who can take cutting-edge research, take cutting-edge ChatGPT-like models or cutting-edge computer vision models, who can take cutting-edge models and who can build real-world solutions, who can build products or services using the cutting edge techniques and technologies. So the expectation of an applied scientist is, hey, he should be able to work like a data scientist, but he should know what is happening in the cutting edge, bleeding edge. They should be able to take cutting edge research papers and employ some of those techniques in the day-to-day work. Now, there is also a fifth role, which is very, very rare. There are only a handful of such roles. These are called research scientists, right? So a research scientist is somebody who is inventing the new algorithms, who is creating completely new algorithms from scratch. Again, you might find some of these roles typically in companies like Google DeepMind or Facebook AI Research or OpenAI or Amazon, some of the research teams, etc. Again, Microsoft Research has a few research scientists. So these people are creating completely new algorithms, and typically they hire people who have PhDs, who have published a lot of research, or typically professors who have done some terrific research work earlier, etc. Again, these roles are very, very few. I'm going to ignore these roles because they typically require a PhD. Except for this role, I will discuss in detail about the other roles. I hope this gives you a sense of the spectrum of roles. Of course, the exact business title could differ from company to company. For example, the banking companies might call a risk analyst who is actually a data analyst who is studying bank risk and stuff like that, right? But broadly, these are the types of roles that we encounter in the data science and machine learning spectrum of things. Okay, before we go to the poll, I also mentioned that I'll give you rough ranges of salaries. Okay, so probably we can cover that in a while, right? So I have another sheet where I'll cover that. Again, for each of these roles, I've just given you a brief overview on, hey, what does this person do? What a data analyst does, what a data scientist does, what a machine learning engineer does, what an applied scientist does, etc. But I'll come to salaries, expectations, for whom is this role appropriate in just a few minutes. But before we go there, I would like to hand the mic to my co-host to conduct a poll and probably answer a few questions. And again, we'll regroup back in just a few minutes, and we'll just try to fill in this whole table for each of these key roles. What are the salaries? What are the skills? Who is this role appropriate and apt for? But before we go there, handing the mic over to my colleague and co-host, who will conduct a poll so that we have a sense of what our audience are and things like that. And we'll regroup in just a couple of minutes.
Thanks, sir. We'll just take some questions as you mentioned. Again, how much Python should we learn for getting job in data science? Rabia, don't worry, I've already shared this question with sir, so he will be taking this up. Data science is useful in any industry. Sandeep, any industry, and you need data. I mean, I don't know if you're a cricket fan or not, but even in cricket now, data analysts and everyone has started coming in. So if it's coming in sports and entertainment, then obviously it will come in all careers whatsoever. So yes, they're in pharma and health tech. We obviously have case studies with respect to, let's say, what are the sort of medicines that you require, the patient allocation, sample size. How do you ensure that even you must have seen health industry and even in the government sector, Ayush, so on and so forth, it's being used in a progressive manner. So yes, the answer to your question is yes, it is very much required. Now coming on to the next question, Priyanka. I've shared with sir, I think he'll cover it. BCom third year, yes you can, but coding is required only if you want to get into data science. Data analyst, it's not that required. We'll cover with all respect to curriculum and whatnot. This will be covered, but I still see a lot of questions on the lines of profile. Let's say I did X, Y, Z. Am I eligible? Am I not eligible? Simple questions like that. Let me reiterate again for people who might have joined late. DSA as an industry is open to everyone as long as you have an undergrad degree in a certified UGC institute. And if you want to get into DS, it's perfectly all right. The only thing required from you would be the hours that you put in, your love for numbers, mathematics, creating dashboards. If that is something that excites you, then yes, this is an industry you should be getting into. No, it will not be a problem, Ajay, if you don't have BTech, as long as you have skills. We have people who did BCom, BBA, and then went into data science and are doing good for themselves as analysts, data scientists, things like that. Again, since time is near and sir wanted us to launch the poll, what I'll do is I'll quickly launch the poll. If you want to connect with team, if you want to connect with people who have been trained by Shrikant sir himself for a free of cost session 1-to-1, please note that this is not a sales call. This will be to understand your eligibility, whether you can actually get into data science or not. How can you better utilize your time, the efforts that you are putting in? Maybe it's September. What happens by November and December, or maybe can you become an able data scientist who is earning well, let's say by February or March? If that is your aim, how do you get into that? What are the tools that you need to cover? Hadoop, Spark, SQL, Python. The list is endless. Python, there are so many libraries, you might get confused. So this is your one-stop solution. You can also ask the team to share Scalar's current module and content, what is being covered, if that excites you. If let's say you came from a non-tech role, what do you need to do? The elementary things to get into data science, that all will also be covered. Sir, I'm taking all these questions upfront so that you can focus on the salary part. Please feel free, guys, to opt in yes to this poll. Again, only if you are serious, opt in yes, and team will reach out to you within the next 2 days. 15-minute slot. So you click on yes and you click on submit for your response to be recorded. Yeah, that is how you do it. I see around 89 responses out of 160. So if only 90 people want to maybe interact, out of them also we see less people have said, so you can opt in yes. Again, thank you, sir, for letting me come up. I would request you please continue with the table you mentioned right now, sir. Over to you, please.
Okay, folks. So let's come back to the discussion of actually filling in this table that I promised you right before handing over the mic to my co-host. So let's try to fill this in, okay, so that we have everything in one page. Again, please don't worry about taking notes. Okay, we will share all of these notes with you on multiple channels like WhatsApp, email, etc., so that you don't have to take notes. Okay, so let's go one by one. Now, the first role that we have is a data analyst role. Let me use the yellow color here. Data analyst, product analyst, risk analyst. I've also heard this term called research analyst in some companies. They all are the same. A typical salary for a fresher in a good product-based company, typically in a good product-based company is typically around 12 to 15 lakhs per annum. Again, I'm talking about good product-based companies. There may be tier 2 product-based companies which may also pay in the 8 to 12 lakhs range. Right? For example, at Scalar, we hire data analysts roughly in that price, in that salary range, especially freshers. Okay, I'll come to skills now. Okay, so this is the approximate for let me also call this out. This is the fresher salary at good product-based companies, right? Good product-based startups or large companies, tier 1 product-based companies. Now, what about skills required for a data analyst? Again, I'll dive into these skills in a lot more detail in just a few minutes, but I'll first list the broad skills. Within each skill, what to learn, I'll just come to that in a few minutes. Broadly, for a data analyst, you have to be good at Python programming, and you have to know Python libraries to perform some data analysis, some data science, plotting, etc. I'll come to what libraries in a few minutes. Next thing you have to know is you have to know SQL fairly well. You should be able to write complex SQL queries because SQL queries help you get the data. Remember, I mentioned a while ago that, hey, one of the jobs of a data analyst is to get insights from raw data. To get insights, they first have to obtain the data. The data may be in a database. How will you get this data in the first place is what SQL will help you. Now, to get insights, a lot of these Python libraries like NumPy, SciPy, plotting libraries are extremely helpful. Also some statistical libraries. These are absolutely must-have. There are some data visualization tools like Tableau, Excel, Power BI that are good to have. Not always must have, but good to have tools. I'll discuss this in more detail later. Again, here I'm just trying to write the broad skills. The fourth important skill that a data analyst should have is they should know how to do exploratory data analysis using concepts in applied statistics and probability. Again, there is also some data visualization in exploratory data analysis. There is also data visualization that exists. Again, the visualization can be done using tools like Tableau, or it can be done using Python libraries. But broadly, these are the skills. Now, for whom is this role most appropriate for? This is most appropriate for absolute freshers. If you don't have any prior work experience, a data analyst is a good way. It is the fastest way because the amount of skills that you need is the fewest. For example, for absolute beginners who do not know programming, who do not know SQL, in our Scalar ecosystem, in our Scalar's data science program, we spend the first 7 to 8 months to cover all these concepts in depth so that some of these people can become data analysts very, very quickly. So this is the fastest and also the easiest role to get into. Similarly, if you're coming from completely non-tech backgrounds, no work experience whatsoever, or even with work experience, for example, non-tech with some work experience, even in such cases, becoming a data analyst is the fastest and easiest way. I'm not saying you cannot become a data scientist, but we see that it is easier to get in as a data analyst. Okay, cool. The next type of role, again, I'll talk about this in more detail as far as the skills are concerned. Now, for a data scientist, the compensations range in good tier 1, good product-based companies typically in the range of 20 to 30 lakhs per annum. Typically, of course, tier 2 product-based companies, the range may be between 15 to 20. Now, for a data scientist, you have to have all the skills of a data analyst, plus you have to know all of the classical machine learning techniques. Now, you might say, what are these machine learning techniques? I will give a detailed list little later. And to what depth, to what breadth we have to know, I'll cover that. Plus, you have to know deep learning techniques, including computer vision and NLP techniques. And of course, you have to know some basics of MLOps so that whatever machine learning and deep learning models you have built, you can deploy them to production. Now, for whom is a data scientist most appropriate for? If you're already a data analyst, then this is super duper appropriate for you. Or imagine you're a software engineer with a few years of experience, maybe 1+ or 2+ years of experience. Because as a software engineer, you're already comfortable with some of the programming concepts, right? And you might be comfortable with some of the MLOps concepts on how to productionize models, how to build APIs, etc. So if you're a software engineer or a data analyst, the data scientist role is the most appropriate career path for you. Now, the third role is a machine learning engineer. Now, of course, a machine learning engineer's compensation is comparable to a data scientist role. Comparable. Again, this could be very similar to data scientist. Of course, there could be plus or minus 2 lakhs difference. Very similar in terms of compensations. Now, here for a machine learning engineer, you have to know everything that a data scientist knows. Plus, you have to know programming very, very well. When I say programming, you have to know the data structures and algorithms much better than what a data scientist knows. Of course, a data scientist has to know some data structures and algorithms, some of the basic data structures and algorithms that are very widely used in data science. But because a machine learning engineer also does software engineering work, they have to know more and more data structures and algorithms. And this is most appropriate for people who are already data scientists or who are already software engineers with more experience. Right? So if you come from these backgrounds, if you're already a data scientist, a lot of people try to become machine learning engineers because they also build the software engineering skills. Next comes the applied scientist role. Again, in the industry, most of the roles that you see are either data analysts or data scientists. These roles are slightly fewer in number. Now, an applied scientist compensations typically range between 25 to 35 lakhs per annum. And the expectation here is, hey, you know data scientist skills, and probably if you come from computer science background, you might also know some data structures and algorithms, but most importantly, you know the cutting edge algorithms. Cutting edge in machine learning, deep learning, and data science techniques. You have to know the bleeding edge of research work. Again, in our Scalers ecosystem, we cover some of the most cutting edge research work that was done in the last few years. We also implement some of them in some of our advanced modules that come a little later. For example, our computer vision module or NLP module, etc. So in our Scalers program, we prepare people for all these 4 roles, just to be clarified there. Okay, so coming back here, who is this appropriate for? This is appropriate for data scientists. This is also appropriate for machine learning engineers. I've also seen some software engineers, some experienced software engineers directly transition to applied scientists also. But typically, I often see data scientists and machine learning engineers becoming applied scientists. I hope this gives you a sense of the key roles. What are the typical fresher compensations you can expect? What are the core skills? Of course, for each of the skills, I will dive deep later. But based on your background, which of these roles is most appropriate for? Again, if you're a fresher or somebody coming from a completely non-tech background, I would recommend that you first become a data analyst and work your way to becoming a data scientist and then a machine learning engineer. That is my strongest recommendation here. Okay, cool. So let's continue our journey. Now, as I promised, I will dive deep into each of these skills. Now let's understand programming and SQL. Okay. So first let's focus on SQL. For SQL, what you should know is you should know the basic SQL, right? Again, you can use any backend, MySQL, Oracle, doesn't matter. You have to be comfortable in SQL to write nested queries well. This is, again, in the real world, we use tons of joins, nested queries, etc. You should know window functions, right? You should be able to write complex SQL queries fairly comfortably. I would say for a data analyst or for a data scientist, the expectation is you can solve hard questions on SQL. Again, on our platform interview bit, you have a bunch of questions that you can practice from. Or if you know platforms like LeetCode, please make sure you're solving some of the harder questions, medium to hard questions, because that's the expectation out of both a data analyst and a data scientist. In terms of programming, the expectation is as follows: that you know basics of Python, you know the inbuilt data structures, whatever inbuilt data structures that you have, you should know. You should know the basics of time and space complexity for the basic inbuilt data structures, for basic for loops, etc. And of course, you should know functions, recursion, basics of classes, basic stuff. Most importantly, you have to know the most important libraries for data science. What are those libraries? There is obviously pandas, which helps you read tabular data and process it. There is obviously numerical Python, NumPy, scientific Python, SciPy. There are also plotting libraries like matplotlib and Seaborn. Right? I'm not saying these are the only ones that you have to know, but these are the must-know stuff, because these libraries help you actually do data visualization or do statistically rigorous analysis and things like that. So these are must-know in terms of programming and SQL, both for data scientists and for data analysts. Now, as far as tools are concerned, tools are mostly appropriate for data analysts. For a data scientist, you may not need the tool. Again, some companies use the tools. Again, what do I mean by tools? I mean things like Tableau, things like Power BI, or any one of these. If you know any one of them, that's good enough. Or even just simple Excel, spreadsheets. Right? Again, this is often not a must know, but a good to know, because with this you can do faster analysis without writing code. And maybe there are people in your team who are not comfortable with code, but you can quickly do analysis just using Tableau or Excel. Again, here, what is important is we should have working knowledge. Now, what do I mean by working knowledge? Again, you don't have to be Tableau certified or Excel certified. Can you solve a real world problem given a real world data set using some of these tools? That's what is expected. Again, please understand that the tools are good to know, not a must know. For a data analyst role, for a data scientist role in top product based companies, these tools are, I've never seen them being asked. For a data analyst, sometimes they're asked. Now, let's come to the third very important thing, which is exploratory data analysis, or data analysis for short. Now, within data analysis, there are two broad systems. One is data visualization. Again, in data visualization, you have to know tons of plots. Okay, there are tons of plots, from simple things like scatter plots, right? So there are the simple concepts called scatter plots, bar plots, histograms, right? Histograms, PDF or probability density function, probability mass function, like your CDFs. All these are probability distributions, probability plots, right? There is also QQ plot. Again, all of these basic plotting and data visualization techniques are super duper important. Similarly, in probability and statistics, you have to obviously know basic concepts of conditional probability. Right? You have to know concepts like conditional probability. You have to know concepts like Bayes' theorem. Right? So you have to know, very importantly, concepts like correlation coefficients, the most popular correlation coefficients that we often use. Then you have to know probability distributions, the popular distributions like Gaussian distribution, Bernoulli distribution, Poisson distribution, exponential distribution, power law distributions. Understand the mathematical properties and applicability of some of these distributions. And obviously, the most important topic is probably knowing hypothesis testing. Again, there are a bunch of hypothesis testing techniques, everything from Z-test, T-test, chi-square test, ANOVA. It's very, very important to know a good spectrum of these tests, because these tests form a very, very important subpart of applied statistics, especially in a lot of product-based companies. They do tons of A/B tests, for which hypothesis testing and all the statistical tests form a very, very important integral component. Again, by no means this list is exhaustive, but these are certainly the foundational stuff. Cool. Next, let's go to the classical machine learning techniques. Within the classical machine learning techniques, you should know basic algorithms like k-nearest neighbor. You have to know logistic regression, right? You have to know linear regression. These are very basic algorithms like naive Bayes. Again, I'm just listing some of the most popular algorithms, certainly basics of support vector machines. You have to know decision trees, random forests, and gradient boosted decision trees, especially libraries like XGBoost, right? Similarly, there is CatBoost, there is LightGBM, right? So some of these libraries are implementations of GBDT. These are all classical techniques which are very popular, which especially GBDTs, random forests, they're quite extensively used. Okay, this is one set of techniques that you have to know. The second set of techniques that you have to obviously know will be all clustering techniques. Things like k-means algorithm that some of you might already know, or some of you may have heard of some of these terms. You have to know hierarchical clustering techniques, right? Hierarchical clustering. You also have to know some of the slightly more complex algorithms like dbScan, etc. Now, of course, you also have to know basics of recommender systems. How do you build a recommender systems using matrix factorization? Right? Again, matrix factorization techniques being some of the popular algorithms which are used for recommender systems. Then you have to know ideas like time series forecasting. Right? If you're given a time series forecasting. Now, what does time series forecasting basically mean? It basically means, hey, imagine if I know the sales of a company for the last 5 years, can I predict what their sales will be in the future? So you're forecasting given some series of values on a time. So this looks like this. This is your time axis. You have some values, let's say sales per day, right? And you already have a series and you're saying, hey, I want to predict what the values will be in the future. These are all basic techniques, very, very fundamental classical machine learning techniques that you should be extremely comfortable with. Of course, some of these may have some mathematics, but you have to understand, again, for each of these algorithms, you have to understand how they work, where to use them, where not to use them, right? So that's also important, where to use and not use them, how do they work, the internals. When I say how, I mean the internals. And you should be able to code them up from scratch. Especially for top product-based companies, you should be able to implement these algorithms from scratch. And of course, you should learn some basic libraries like scikit-learn, XGBoost, etc., through which you can implement some of these also. Again, the most important thing is where to use and where not to use, along with understanding the mathematics. When I say internals, I mean the mathematical underworkings, how everything works internally. That is super duper important. Now coming to deep learning. Of course, deep learning is a very vast area right now. We can break this down into 3 topics. There is computer vision, there is multi-layered perceptrons, there is computer vision, and there is natural language processing. Now, in multi-layered perceptrons, this will give you basic concepts like backpropagation, right? And simple, fully connected algorithms, right? Concepts like distillation. Again, I'm just giving you, again, all the concepts of how do you build a deep neural network. There are a bunch of concepts here. The list is quite extensive. I'll show you our website where some of these topics are given in more detail. Right? We can also share our brochure a little while later, where you can get much more detailed list. But there are a ton of concepts here. Similarly, in computer vision, you have to know the most popular CNN architectures. Again, there are about 10, 15 very, very fundamental convolutional neural network architectures. I can give you a simple example. There is something called as MobileNet, right, which is used to build machine learning or computer vision models, right, anywhere where your camera is used on a mobile phone. This is just an example. There is something called as EfficientNet. There is something called as ResNet. So all these foundational computer vision models you should know. Similarly, in NLP, you have to know concepts like LSTMs, GRUs. These are all called recurrent neural networks that can process a sequence of things. Like words, text is nothing but a sequence of words, right? So you have to know some of these concepts. Equally importantly, you have to be very, very comfortable with more recent techniques called transformers. Within transformers, you have to know the foundations of GPT algorithms. And within GPT algorithms, there is one variation called ChatGPT, which has become very, very popular over the recent past, right? So you have to be very, very comfortable with GPT algorithms. You have to know related transformer architectures like BERT. Again, for all of these, you have to know how they work, how the internals of how everything is working. Why do they work? Again, that's something that I forgot to mention here. You have to know why do these algorithms work. Again, where to use and where not to use, which all boils down to which all boils down to applicability. Similarly, you should be able to implement some of these algorithms from scratch using popular libraries like TensorFlow. Again, there are these very popular libraries like TensorFlow, Keras, or PyTorch. You should be able to implement some of these algorithms yourself, some of these architectures yourself. Now, having said that, the other thing is ML ops and basics of machine learning system design. I'm not saying software engineering system design, but basics of ML system design. Here, you should know how to build an API using Python, right? How to deploy a model using basics of Docker plus Kubernetes. You have to know how to use, how to process data using the big data system Spark, right? How to build data pipelines in Spark. Again, you don't have to be expert at it, because all these are very, very complex topics. Spark itself, we can spend months learning Spark. So you have to have working knowledge. You have to have working knowledge of these systems, not necessarily expert. You don't require expert knowledge because that's what big data engineers and like world-class software engineers have. But if you have some of the basic working knowledge of docking Kubernetes, API, Spark, and if you know the basics of some simple cloud systems like AWS or Azure, if you know how to use our Google Compute Platform, if you know how to get started, how to use some of the basic features, you don't have to have certifications or deep expertise, not deep expert. Just basic foundational working knowledge, that's good enough for most data scientist roles. Okay, cool. Now, one thing that I have to double click on, and I just want to be very clear. While all these techniques is one side, being able to solve real world problems is probably the most important thing that I can ask you to have. Again, you might know all the mathematics, you might know all the libraries, but if you can't solve real world problems, it's useless. I would say this has more than 50% weightage in any interview or even in the real world. If you become a data scientist, for you to succeed, while learning all the mathematics, coding, all of that is important, solving real world problems is probably the most important. Now, I have some questions for all of you. Again, I just wanted to ask a few questions, okay? Again, please answer in the chat window. I would love to see your responses. My first question, imagine you are a software engineer with 2 years experience. What are the most appropriate roles for you? You're already a software engineer, you're working, you write code, you write production code, you have 2 years of experience. What are the most appropriate data science roles for you? Okay. Again, as we just discussed, a data scientist is a very appropriate role. Similarly, a machine learning engineer is also a very, very appropriate role for a software engineer with about 2 years of experience. Next question. Imagine you have 3 years of experience and you worked as a marketing executive or a sales executive. What do you think will be the most appropriate career transition for you within the whole spectrum of roles that we have? Again, please use the chat window to type your answer. I'll wait for a few seconds. Again, I just want to make sure that you've understood at least the corresponding roles based on backgrounds. Cool. So a data analyst is the most appropriate career transition. I'm not saying you can't become a data scientist. I've worked with a few learners who come from these backgrounds who have become data scientists in the past, but the easiest and the most realistic outcome is a data analyst. Now, imagine you're somebody who has worked in software testing for 5 years. What could be a good career transition for you? Testing, which means you've not written a lot of production quality code. You have 5 years of experience, but you've worked in IT, but not necessarily in hardcore programming. Okay. So for somebody with this experience, sometimes these people end up as data analysts, but we also see these people end up as data scientists quite often because they have more years of experience and they have the technical know-how. While they may not have written a lot of code, they've at least seen code. They understand code. They come from computer science background, right? So while some of them become data analysts, we have also seen some of them becoming data scientists also. Again, this outcome depends on how comfortable you are with coding, how comfortable are you with the machine learning and deep learning techniques, and how comfortable are you with solving real world problems using these techniques. Now, next question. Imagine, I don't know if there are enough people with this background in this session, but imagine you're an IT manager, a software engineering manager with 10 years of experience. What could be a good career transition for you? You're already a manager in an IT company with 10 years of experience. I'm sure there are very few people in this session who may have that background, but that's okay. If you have that, great. Okay, so typically people with this sort of background, we typically see them transitioning to a data science manager. Typically, data science manager or a machine learning manager. The reason being, typically as a data science or machine learning manager, all of your managerial skills, managing software engineers, gets carried. Similarly, as a data science manager, you manage data analysts, you manage data scientists, you also manage software development engineers. So a lot of your managerial skill will work here, is translated to this role. And given that you've learned data science, you've become very comfortable, you've built probably a few data science modules while being an IT manager. Again, if somebody is coming from this sort of background, if you want to transition, make sure whatever data science you're learning, you're trying to implement some of that in your current role. That's how your career transition will happen, right? I hope this gives you a context on what to expect as a most realistic career outcome given your background. Cool. Again, I would like to hand the mic to my co-host who will share a few success stories and probably take a few questions. Again, there are a few questions that my team is collating that I'll answer at the very.
Thank you so much for the explanation. Even people are writing that it's working great for them with respect to the clarity. Um, Again, as sir mentioned, that it's important to have good background and experience if we want to get good success. But a lot of people are still, questioning whether what will happen if they don't have experience. I think Ajay and a few more people are having this issue that I have no experience. Then what? So what you can do is, do not worry. Again, what I can do is I can start sharing my screen, and I need your help, ladies and gents. I'll share a very important in-house channel that we have here at the Slack application. Can you see my Slack with the daily success stories by any chance? Yes. And can you see Academy and DSML placements? Guys, yes, no, maybe. Thanks, Philip. So I'll take Philip's yes for everyone's yes. This you can see is our in-house channel of people getting placed. Again, you can see right from Academy, Scalar, and Data Science Scalar, 25 LPA, 14 LPA, 20 LPA, 22 LPA, 25 LPA, people who joined in December, January, February. Some of them had the experience, some of them did not have the experience. But the idea is that even if you do not have, you can start in a very good analyst role, good paying analyst role, seen 10 LPA, 12 LPA onwards. Depends upon how well you perform and what is your skills that you bring in while you're solving those assignments and things like that. So this is how we ensure that people are rewarded enough after their hard work. So this is just as a sign of motivation for everyone who might still have the apprehension, what will happen if if I come from a different background. That being said, sir, I think that's you wanted me to share. I think we have done with that. I would like you to, sir, please proceed ahead, and I'll keep giving you questions for the same, sir. Over to you, please.
Cool. Again, thank you very much. And let's come to the roadmap. Again, this is something that we often get asked, which is, hey, what is the roadmap for me? You've told me all the techniques, all the skills, you've told me about careers, all of that. But can you show us a roadmap on what to learn, what is the sequence to learn and stuff like that? For this, I'll take you to our Scalar's website. Okay. Again, there are three things that are very, very important before I go to the website. You have to have reasonable breadth of knowledge. You have to have good enough depth of knowledge in some areas. And most importantly, you should have applicative knowledge, which means you should be able to solve real world problems using that. Again, the roadmap that I'm going to show is something that we have designed at Scalar by talking to hundreds of companies and hiring managers, also with our own experiences over the last few years of helping people transition to data science careers. Okay, so cool. So let me just come here. Okay, so let me just take you to this. Again, by the way, I don't know if if any of you have seen our, this is a dashboard, by the way. This is the dashboard of one of our learners, of one of our cohorts. And if you observe, one thing that we do here is, hey, for example, this learner learned, this was 24th of March, this learner learned correlation tests, right? And when in a class, they learned about Pearson correlation, Spearman rank correlation. Right after that, they have a business case that they're solving. Then similarly, the next week, they're learning about basics of feature engineering. Again, they have case studies, right? So our whole program is designed with lots of case studies. We have actually 80 plus case studies, some of which that we solve in the class, some of which that learners solve as homework, and then we bring them back to the classroom, etc. Similarly, learners learn a few classes on hypothesis testing, and then we say, hey, here is a business case, let's solve these problems. So just wanted to show you how we have organized it. Again, I just want to double click on the importance of solving real world problems. You have to solve tons of real world problems without which you will not learn, you'll just learn theory. I just wanted to double click on that point. That's why I'm showing you this dashboard. Now here is a page. This is a curriculum outline. Again, we have beginner audience. So we have broken everything into beginner, intermediate, and advanced. Beginners are people who do not know any programming, who do not have any background, maybe people coming from non-tech background, sometimes freshers, etc. So we spent about 4 months, the first 4 months, we spent on teaching basic tools like Tableau, Excel, SQL very importantly, and also foundations of Python programming. This is where we spend. Again, if somebody already knows these concepts, they become intermediate learners, for whom we spend another 4 months learning Python, teaching Python libraries, the data science libraries. We also spend a good amount of time helping them understand probability and applied statistics. Equally importantly, solve a lot of real world cases. So this whole module of product analytics is all about let's solve more and more real world scenarios using all the techniques that we have learned till now. Now, if somebody already knows all these concepts, they become an advanced learner for us. Somebody who is already a data analyst, let's say, they already know most of these concepts. So they become an advanced learner. So for an advanced learner, we dive deep into advanced concepts of Python, like multi-threading, dive deep into object-oriented programming, some of the more software engineering heavy concepts. Then we introduce all of the mathematics for machine learning, like optimization, like stochastic gradient descent, calculus, all of those concepts we touch upon. Then we go into introduction to neural networks and machine learning, where we teach simple neural network models, simple machine learning models. Then we spend a lot of time on all the supervised learning algorithms like XGBoost, right? Some of the techniques that I've talked about. Then we spend, again, a good amount of time on unsupervised learning algorithms like K-means, hierarchical clustering, recommender systems, etc. Then we spent another 3 months, because people have already learned a lot of foundations, they're very strong foundations by this point of time. They spend a good amount of time going through neural networks, computer vision, NLP, etc. And then we have modules. We have some of these modules, or elective modules as we call them, or additional modules, where we have ML Ops. This is like a 1 week long. Similarly, people who want to learn advanced data structures and algorithms for machine learning engineering roles, here we have like a 4 month long module. So this is how we have structured our program. Again, for those who want to dive deep, if you want to dive deep again, for Tableau and Excel, we have some of these concepts. For SQL, what all concepts are very, very important. For beginner Python, what do you learn? Again, by no means these are very, very detailed. These are still high level, but you get to know what are the most important stuff that you should know. Right? I mentioned some of these in my dive deep, but if you want to dive deep further, here is a place that you can go to. I hope this gives you a sense of what all techniques are important, how deep to learn, and how to learn from a practical standpoint. But let me also emphasize on this, that please solve real world problems. This is what, at least in my own experience of teaching machine learning for the last 6 years, this is what creates the most value. Again, in our program, We have, as I mentioned, we have 80 case studies that we solved throughout the program, some in classroom, some as assignments. And again, there are about 20 odd case studies that we've collaborated with companies. We went to a bunch of companies, typically top product-based companies, and we said, hey, please give us the problem that you're solving. Of course, we anonymized some of the data and we said, let's bring them to the classroom and we want our students to solve them. But again, if you want open source real world problems, please go to this website called Kaggle. Again, I'll give you an example of a very interesting problem that I was solving very recently in one of the batches. So we said, hey, imagine you have a self-driving car, right? Imagine I can put a small camera on the windshield of the car. Suppose this is the windshield. Of course, there is a driver sitting here. So suppose I put a small camera. The camera is looking at, let's say, the driver. It's like your selfie camera of your smartphone. If it's looking at the driver, suppose the driver is sitting here and driving. Now, can you detect if the driver is distracted or not? It's a very important problem, very important safety problem. Can you detect if a driver is using a smartphone, talking on the phone while driving? This is very, very important for commercial travel. For example, imagine any e-commerce company that is shipping huge trucks. These are massive trucks from one place to other place. You don't want your driver to be distracted during driving because it's a major safety issue. Or if you're working in a supply chain company, you don't want your drivers to be distracted. So it looks at the driver's face, again, it also looks if the driver is exhausted. Then it simply beep an alarm and say, please get some rest, stop the vehicle and get some rest. So this is to help the driver to take appropriate rest and primarily to save him. So this is to detect distracted driving, to detect whether a driver is tired or not, if he's almost blinking his eyes or some of these things, right? The most important thing is we make our students build a system, a prototype of a system like this in the classroom through assignments, and we cover many of these algorithms. I was talking to you just a while ago, I was talking to you about an example called MobileNet, right? So we ask our learners to use this MobileNet architecture and convolutional neural networks and say, can we deploy this on a low compute device like your smartphone? This is a real problem that learners have to solve. Again, my suggestion is you can solve any of those problems like these. As you're learning data science, it's very important to solve real world problems like this. If you can solve a problem that you know, for which you can collect some simple data, that's great. Or else you can go to platforms like Kaggle where there are tons of publicly available data sets from which you can solve problems. For example, I can show you this. Okay, so before I go here, before I hand over the mic to my co-host. So for example, this is Kaggle.com. On Kaggle.com, just click on competitions. You have tons of problems. Right? This is a medical problem of Parkinson's detection. Parkinson's is a terrible disease that people get as they grow older. Again, this is also a Parkinson problem. This is about can you predict a student's performance based on the game that they are playing? Right? This is about detecting birds. Right? So this is about image matching. Right? So there is also a problem in protein foldings. Right? So there are tons of problems here. This is about house prices. I'm sorry. This is about time series forecasting of store sales. I was talking about this, right? Can you predict the sales of the store in the future? So you have some data sets, you have some competitions from which you can pick some of these. This is a very nice problem from Google where they want to detect sign languages. If somebody cannot speak and they're showing something in sign language, can you detect it? And there is also a competition price for this. There's also prize money for this. So pick up any of these problems, try to solve it. Make sure you're solving good problems, real world problems. You can pick a problem like this driver distraction, or you can pick some examples from Kaggle. Okay, I hope this gives you a sense of it. Again, before I go there, just one more point I wanted to touch upon, which is when you're solving any problem, right? When you're solving any problem, please solve it very, very well. And in your resume, make sure for the problem, you share the code on GitHub. Please upload your code, document your code, please put it on GitHub. Write a detailed blog, let's say a 2,000-word blog, explaining the problem and explaining your project. These are called portfolio projects. Also, you can create a short 3 to 5 minute demo video explaining the work you've done. This is what helps you enormously in showcasing. Again, this is if you're doing a project, please showcase that project. Again, I often hear people complaining that, hey, I've learned some of the data science stuff, my resume is not getting shortlisted. Please put at least 2 to 3 good rigorous projects like this. Your chances improve significantly. Right? Cool. Again, I will hand over the mic to my co-host, who will share the brochure with you, the brochure of Scalar Data Science and Machine Learning program, which has more details, and who will take a few questions.
Thanks, sir. Again, that was a very quick this thing, but yes, thanks. You're right. Thumbs up on that. This thing. Perfect. So the browser we have added, and yeah, I think this is good. Questions? How much Python? I think this has been addressed a bit, but we will cover again. Sir, if you can please cover again, that'd be great. Course bean and all we'll take in some time. Only for analyst? No. Idea is that you cover analyst, then you cover data science, and then you cover machine learning. So you cover everything under the umbrella for best career objectives. Again, data analyst does not require coding. Data science does require coding with Python, but you'll find it fairly easy even if you have no idea. We'll start everything from scratch in the first line of coding, and it's very similar to knowing good English. So that is that. Course duration we will cover in some time. Do not, Rabia, do not get into it as of now. My suggestion would be not get into such hard terms if you have no idea about that. Only end up confusing yourself. How to get raw data for solving real problem? Fauzan says Kaggle is your best friend. Open resources. Perfect. I think a lot of questions we have taken. What is free score? 6 years experience in business and engineering. Yes, it will be Shivangi. A lot of people will also DMing me if we are testers in QA. What about us? So it is only beneficial if you want to get into this industry. So you might want to look at it from that end. Yes. Vishal, we have covered. There is Abdullah. It will be beneficial in any industry that you want to get into it. But sir, a lot of questions are coming about Scalar in general, our fee scores, our curriculum, what is covered, the duration. So maybe if you want to take some questions around that, answers around that, and I'll maybe cover. Where did it stop, sir? Yeah, over to you, please, sir. Thank you.
Cool. So now let me give you a brief overview of the Scalar's Data Science and Machine Learning program. Again, you can find all of this in our brochure and in the website that I showed you earlier. If you're a beginner learner, we expect you to spend about 15 to 18 months to become a data scientist. Typically, at the end of 7 to 8 months, you have learned everything required to become a data analyst. But we don't want you to stop there. We want you to continue learning in the journey so that you can become a data scientist. If you're an intermediate learner who already knows some programming, who's already comfortable with SQL, Python programming, etc., for you to transition to a data scientist role takes about 11 to 16 months. These are approximations. Of course, every learner has their own pace of learning. Some people might struggle coping up. Some people might move fast. So I'm just giving you an approximate range. If you're already an advanced learner who already knows some of the data analysis techniques, to become a data scientist takes about 7 to 10 months. These are realistic estimates. These are not like too simplistic or too blown out, right? We want to give you a realistic estimate of the effort. And we expect that you will spend about 12 to 15 hours a week. An average student is expected to spend about 12 to 15 hours a week on the programming, including the classes. We have classes 3 times a week. For 3 days a week, we have 2-hour classes, typically in the evenings, but we also have some morning classes. Again, you can choose whether you want to be in an evening class or a morning class. But this is the effort estimate. Again, there is no shortcut to becoming a data scientist or a data analyst. You have to put in this effort. If there were a shortcut, I would tell you that. Now, again, what are some of the things that we focus a lot in our Scalars program? First, we have live classes. As I was just mentioning, we have 3 2-hour classes a week where an instructor, very often someone like me or somebody who has worked in the industry, all of our live classes are by practitioners, which means these are people who have been data scientists, data analysts, senior scientists who have built systems in the real world. They come and teach so that they can teach you from a practical standpoint. That's why I said solving real world problems is the most important thing. And the best people to teach that are the people who have been there, done that as practitioners. All of our curriculum is very, very industry centric, as I was telling. We keep going back to the industry every 3 months. And we keep saying, hey, what are the most important skills for someone to become a data scientist? What are the most important skills for someone to excel in their career? Right? And we keep modifying, improving our curriculum every now and then. Sometimes we add additional electives for people. Sometimes we modify the existing content if some subset of techniques are not very important, or there are alternative techniques which have become more popular in the recent past. Similarly, we have about 20 one-on-one, approximately about 20 one-on-one mentorship sessions. All of our mentors are working professionals in the industry. They're either data scientists or data analysts or people with a few years of experience. We want every learner at Scalar to have this one-on-one mentorship. Some of these 20 sessions are mock interviews so that you know where you stand, you know how well you have understood, what are your gaps. The mentor, who is already somebody who's working in the industry, can help you fill those gaps. Similarly, we have some mentorship sessions where you can discuss with the mentor to plan your journey. You can say, hey, I'm struggling here, what else should I do? So there are also career guidance as well as mock interviews amongst these 20 sessions. These are one-on-one sessions with an industry professional so that you have a buddy, not just instructors, but you also have a buddy who is someone very similar to you who has transitioned into data science roles in the past, right? We have about 80 plus business cases, both in our classrooms, assignments, homeworks, all of that included. And all of these business cases are real world problems that we want you to solve on regular basis. We have a terrific team of teaching assistants who are there to support you whenever you're stuck. Suppose you're solving an assignment, you're stuck. You can just come onto our platform, raise a TA request. You can chat with the TA or you can raise a video call request. Our TAs are there to help you instantaneously to resolve anywhere you are stuck. Similarly, we have a great career support and placements team. They help all of our learners once they clear all the concepts, once they're comfortable with the concepts, once they've done some mock interviews, once they've cleared some mock interviews, our career support team connects them to the appropriate roles. Again, we have had terrific success in terms of helping learners make a successful career transition. Most importantly, I have to emphasize this with 3 stars. We have a great peer group and alumni. We have about 30,000 alumni and peer group. A lot of learning happens through peer group. I cannot emphasize that. I've seen so many of our Slack groups and WhatsApp groups where learners discuss about a problem which they have in assignments. We encourage them. We want you to work collaboratively, not copy-paste solutions, but at least discuss about a problem, come up with the right solution and solve them. You have like-minded, motivated peer group and nothing beats that. Of course, we also have alumni who do a few sessions with whom we can have some one-on-ones, or you can chat with them on our Slack group, or they sometimes also help us with careers. Imagine their team has 5 positions. They come to us and say, hey, can I hire a bunch of people from the existing pool of learners? Right? So it's a great teamwork that happens. Cool. One more question that we often get asked is, hey, are there some interesting resources for me to get started? There are broadly 2 resources that I can point to. Both these, again, the Scalar Topics is a free resource that we have built at Scalar. Let me just quickly show you Scalar Topics. Again, while I'm doing that, I would request my co-host and some of my team members to collate all of the questions so that we can pick some of the most often asked questions, frequently asked questions, and I can show you some of these. Cool. So here is a platform that we have. It's called Scalar Topics. You can just go to Scalar's website. You'll see Scalar Topics, or you can go to scalar.com/topics. Here, these are recorded introductory courses that we have created, that some of my colleagues and I have created. For example, you have courses on Java, you have courses on Python, you have courses on database management systems, you have courses on JavaScript, etc. If you're interested in the data science program, you can just go click on data science here. Here you will get to see a bunch of courses. Some courses on Keras and TensorFlow for deep learning, data science for beginners, exploratory data analysis and data visualization, which I created with the help of some of my colleagues. Similarly, if you're interested in some software engineering aspects, you can go through some of these introductory topics on software engineering, like dynamic programming, SQL versus NoSQL, all of this stuff. Feel free to check out some of these resources. They are very helpful in getting you started. Right? They are free. You just have to log into the Scalar platform and you can access all of these. Similarly, I was also talking to you about some of the books that are available, right? So here is a very popular free book. Again, you can just Google search for it. You can just say Think Stats book. This is a very nice introductory book about applied statistics. Again, this book assumes that you know programming. If you already know basic Python programming, it helps you teach probability and applied statistics from a practical standpoint. This book is freely available. The code used in the book is also freely available, so you can use this. Of course, there are a bunch of books. Again, here is a simple blog, right? Again, you can just Google search for best Python books for data science in 2023 or 2020, whichever year you want. Again, just ignore the year because that's okay, right? So if you just go through some of these, again, these are all some very simple, nice books to get started. But please be warned, a lot of O'Reilly books don't go deep into the internals. They're very coding focused. They give you the intuition, they give you some of the code, but they don't go deep enough for a product-based company. So just giving you that note so that you don't miss that. This book does not go into internals of lot of probability and statistics, but it's a very practical book from a real world standpoint. I like this book personally. Okay, so I hope these free resources will help you get started to start exploring data science. And of course, we always have the Scalar Data Science and Machine Learning program in case you're committed to spending the 12 hours to 15 hours a week over the next few months. If you want a fast-paced path with live instruction, with mentor support, with mentors helping you, with all of our core things that I just mentioned a while ago, we're anyway here to help you. Cool. So with that, again, I see my co-host and some of my team members who have collected some of the most widely asked questions. Again, I'll take a few questions and hand over the mic to my co-host. Okay, cool. So let's take some interesting questions. Okay, the first question, again, I'm just looking down because I have my team thankfully collated the questions on the other screen and they've just shared that screen with me. Just let me scroll this. Give me a second. Just give me a second, please. Cool. Okay, so the first question here is very interesting. Will ChatGPT take the job of data scientists? I get this question very often. So the way I look at it is this. ChatGPT will help data analysts, data scientists, software engineers become much more efficient. This is very, very important. Again, think of it like any programming tools. For example, there were a lot of libraries that were built for Python, which enabled data science folks to become much more efficient. Because I worked in the data science field before there were all these fancy libraries. I've sometimes implemented some of these machine learning algorithms from scratch myself. It was very time taking. Today we have so many libraries which have made us more productive. ChatGPT, as I see it, is a phenomenal tool to help improve the productivity. Now, if the productivity improves, it will also create more jobs. I'll tell you why. Now, now every company, look at what happened with software or with web development. Web development, there are so many tools and libraries and frameworks, right? Like Angular, React, all of this. It made web development simpler, easier, and more productive. Now, every company in the world wants to have a mobile app. They want to have a web app. Same thing will happen with data science. As some of these tools like ChatGPT like stuff helps people become more productive, as it helps people improve their analysis. What happens is every company now wants to have a small team of data scientists to create value out of the data that the company already has. So the number of jobs will improve, the reach of data science and the applicability of data science will go to almost every field, from medicine to astronomy to zoology, you name it. It's already being applied, but it'll just explode thanks to tools like ChatGPT, because ChatGPT enables data analysts and scientists to become more productive. So I don't see this as a threat. Of course, remember, ChatGPT does not have the human intuition. What I mean by that, let me be very clear. What I mean by that is this. If you're a data analyst or a data scientist, you work with the business team, understand the business problem and solve it. ChatGPT could be a buddy next to you who is helping you do some of that analysis. It cannot think from a business standpoint yet, right? Again, that business acumen, that human ingenuity, human creativity, that human ability to connect to the business problem or work with colleagues, all that is necessary. Of course, it will help you write probably some SQL queries, it will help you write some Python code, which means it's improving your efficiency, not replacing you. Right? I hope that is clear. Okay, cool. So next question is, what is the educational background required to become a data scientist? I would say skills are more important. If you have a bachelor's degree, typically most companies expect you to have some bachelor's degree. Right? Even a master's degree is not mandatory nowadays, or a PhD. PhD is only applicable if you want to become a research scientist at a top company. Then you have to publish a lot of good research work also. For a data scientist, if you have a bachelor's degree, if you have the real world skills of doing data analysis, you're good enough. For example, I know somebody who has a 3-year bachelor's degree, who used to work in a HR company, in a HR role. That person, fresher, I think he has about 2-3 years of experience in a HR role. And he was one of our learners, and he learned both data, he learned all the data analysis, he learned some machine learning techniques also. He had an offer to become a data analyst and also a junior data scientist. He does not even have a 4-year bachelor's degree. And such transitions are possible, because what companies are looking for more than degrees is the core skills. Can you solve real world problems using data analysis, using SQL, using Python, using machine learning techniques? That's what they care about. But most companies I see often ask for at least some bachelor's degree. There are exceptions, obviously. Cool. What is the difference between data analytics and data science? Good question. So data analytics is all about building data visualization, dashboards, doing some data analysis, etc. So data analytics is closer to a data analyst role. Of course, some data analysts also not just do data analytics, which is plotting, but they also do deep, rigorous statistical analysis. Data science is more of what a data scientist does. Of course, data analysts also do some data science because they use mathematical tools like applied statistics, etc. But data analyst is more about drawing, plotting things, building dashboards, etc. Data science is more about doing analysis, whether it's a data analyst or a data scientist, and building machine learning models, deploying them, building deep learning models, etc. Okay, so the next question here is, why is the fees at Scalar on the higher side? This is a very valid question, very good question also. So when we designed the Scalar's data science program, here is how we thought. So we asked ourselves, what is needed to build the best program? That's where we did all of this analysis, and we used all of our insight and talked to a lot of people. We said, these are the stuff that we need to have a great learning experience. We need live classes by practitioners. We want to bring you the best practitioners to teach you in the class. We wanted the curriculum to be industry-centric. We want to have a good number of one-on-one mentorships. We wanted to have tons of business cases, some in partnership with companies. We wanted to have a terrific TA team, terrific career support team, terrific community, etc. So first we start off by saying, if we have to speed up somebody's learning and give them the best learning so that their career outcomes are very fast. They are fast-paced. Their career outcomes are also like, if people are putting in the effort, their career outcomes are more or less like, they will get it if they put in the effort, right? For that, what is required? Then we got all of these and we said, to provide this, what does it cost us? Again, hiring the best practitioners from the industry is not cheap. Let's be frank there. Having a ton of very good TAs who can answer your questions at any point of time is not cheap. Having one-on-one mentor sessions with data scientists and data analysts in the industry is not cheap. All of these things cost money. And then we said, hey, how much does everything cost? And we took that pricing and translated it, and that's why our price is like this. Again, to give you an analogy, Apple builds brilliant smartphones. Again, even Samsung builds, or Google sometimes through the Pixel Pro lineup, they build some great smartphones. The great smartphones are expensive because the research that goes into them, the technologies that are put in that, the software that is there, they all are expensive. They all take monetary resources. That's why they're expensive, right? So at its very core, at Scalar in the data science program, we want to be the Apple of literally learning, the best experience, the best product, the best service, the best learning experience for people without any shortcuts. And of course, we spend a lot of time on researching how to best teach, just like the way Apple spends a lot of time on researching how to design the best chips. Right? I hope that analogy makes sense. Cool. The next question here is how to advance from non-tech or other profiles to data science. I think I've covered this briefly already. In essence, please make sure if you're coming from a non-tech background, your first step is to learn Python, SQL, data science, basics of data analysis, basics of Tableau, Excel, and tools like that, so that you first become a data analyst. That should be your first step. Again, I'm not saying you should only aspire to become a data analyst. First, become a data analyst. And then as a second jump, become a data scientist. That's what we recommend all of our learners also, especially beginner learners who come from non-tech backgrounds. Okay, next question. Again, this is very often I get asked this. I'm not good at mathematics. Can I still do the data science program? Very, very valid question. Again, to be very frank with you, I see, unfortunately, that a lot of mathematics we were taught in school, we were not taught from a practical standpoint. For example, we learned a lot of calculus in your 11th and 12th class, those people who come from the math background. But we never learned why we are learning this calculus. When we learn machine learning techniques, we learn something called optimization, which requires calculus. When we learn calculus here in our data science program at Scalar, we teach you from a practical standpoint and why we need it. Similarly, when you learn simple concepts like probability, right, conditional probability or Bayes theorem, we don't just write equations for you. We explain that from a practical standpoint. Again, I've been very fortunate. I've been very, very fortunate to have taught people who were really frightened of mathematics. I taught them probability, statistics, some advanced mathematical stuff. And by the end of the module or by the end of the course, they loved it because they felt, hey, I wish I learned like this in my 11th and 12th. Probably I would have become very good at mathematics by now. So we believe that if mathematics is taught from a practical standpoint, where intuition is first built. First we build intuition, then we come to equations. We build intuition mostly through drawing diagrams so that you get a sense of what's happening underneath the hood. Right? So diagrams are very, very important. Real world applications are important. Equations come last. Because once you have the intuition, once you know the practical side of things, getting the equation, you can derive it yourself. That's what we do in the classroom. We derive equations from intuition. Right? So if you're frightened of mathematics, please keep that fear away. Start from a blank slate, and I'm very confident if you learn the right way, you will enjoy mathematics. Again, my most favorite topics to teach are math-heavy topics because I enjoy breaking complex mathematics down. Right? Again, cool. Again, these were some of the most popular questions that we often get asked, and I think my team has collated some of these. Again, I'm handing over the mic to my co-host, but before that, thank you very much for taking the time to attend this session. I hope this was fruitful and helpful. Again, a ton of thanks to my co-host who has helped us organize this whole session, and thanks for some of the polls, some of the questions that you've handled, also for collating these questions that I've just answered. Thank you very much, folks.
Before we move ahead, for people who had missed out on the poll, now is a good time to say yes if you would want to connect with the team free of cost, if you want to understand the curriculum, what are the requirements, what are the timings. So the timings are thrice a week, evening time, just like how you have joined in. So around 8 to 10 p.m., 9 to 11 p.m., alternate days. And on days that are there no classes, then you will have homeworks and assignments. There are also classes over morning time. So you can connect with the counselors and let them know about the preference that you might have. With respect to, let's say, some of you are asking about softwares and whatnot. Do not worry, everything will be provided to you by the team. Only thing that you need is a good laptop and a good silent environment where you can practice, because classes will be live. So the instructors will be there with you, just like Shrikant Verma, Suraj Asija, Mohit Unyal, Amit Singh. Then you have Nikhil Sanghi, Shivang Agarwal, Harshit Tyagi. So all these instructors, have had good experience, and they will walk you through the concepts. And depending upon your experience, you join either beginner, intermediate, or advanced batch, and then progressively your journey moves ahead. So this is how it will be. So just launching the poll, I can only see 27 responses, and I see 91 people here with me. So this is your only and final chance, guys, if you want to interact free of cost. And do not worry, this will not be a sales call, but only if you're serious, please opt in yes. This poll ends in the next 10 seconds, so you have very limited time to make your decision. And all these people have been trained by Shrikant sir himself, so they have good command over what they'll be, addressing throughout. Perfect. The poll is ending. Again, guys, come on. I would like you to interact. Any response is fine. At least interact so that we know that you're still here listening to it. Perfect. Mandar, you can connect with the team. They can let you know. Balakrishnan, I have answered your question way ahead in the chat. I think you have missed out. One request is please don't spam. I have addressed that if the lectures get missed, every live lecture is also recorded so that you can go back and watch. Just in case, as it seems that you must have missed out. I'm just reiterating. So I hope that is clear. Again, Shrikant sir has dropped off since he has a class at this time. We'll be going over there, but I'll just keep taking your questions. Perfect. Ajay, good question. We also have throughout your course, it also includes your soft skills. So you will be also going through mock interviews, not from just the TAs and mentors, but also potential HRs who can help you understand how to speak, what to speak, when to speak, where to speak, all these things. So do not worry. English and other soft skills will also be addressed to some capacity. Software requirements to join the class and software programs. Akanksha again had mentioned that all software requirements will be covered by the team. You do not have to worry. Rakiba, I apologize. I did not understand your question. Do we have any future classes? Unsure what the context is. Yes, fee structure. So now coming to the fee structure, fees are actually different for everyone. What happens is it also depends upon your entrance test. So all of you would have to compulsorily give one entrance exam. Depending upon your entrance exam, you get scholarships. Better your score, higher your scholarships, hence lesser your fees. So there are multiple but limited attempts to give the admission test. Hence, I cannot comment as to what yours course fee would be compared to someone else. Rakiba, this course, how you want to start? Had you opted in yes to the poll that I just launched some time back for the counselors? If you had said yes, you can connect with them and let them know about your preference. They are the best people to guide you. Perfect. That will help. Arbaz, we have already covered about the course duration. Let us see what all requirements there are. Yes, there are also, just wanted to reiterate for people, I think some of you are also DMing me. Again, the course structure, for example, if you join in at a beginner's batch, so as sir also mentioned, you'd be here with us around 9 months, 10 months, 11 months, around that duration. And again, the entirety of the program would be live. There are also some offline meetups that we do across cities. So if you're from Delhi, Bangalore, Chennai, or some major hub, we ensure that all of you are also connecting with each other and networking offline before you sit for your placements, and when companies start coming to Scalar to pick you up. So that is also there. Good community understanding. Saurabh, yes, we have already covered about placements. Aniket, in that sense, you can give the entrance test and you would most likely be in the advanced batch. Again, from beginner, and this is all the duration would be. Course fee you can expect around 3.6 L, and this is how the duration and the categorical amount would be. But there are affordable EMI options also. EMI start at around 8,000, and you have both no cost EMI and other options as well. There's also 2 weeks of money back guarantee. So if you have other questions, you get refund, no question asked, but that is only for a limited amount of time. So give it a shot, see how it goes for you, and you can make your decision in and around that. Given entrance test of mathematics, my score is 91%. Ajay, what are you doing over there? You should also start teaching mathematics if that is the case. You can be a good subject matter expert if that is the case. But again, I see majority of the questions have been addressed. Did I? Sandeep, I don't remember saying that. AI will replace DS or not? I think this is already covered by Sir. Vishal, we have covered that. Akanksha covered. I'm just going through the questions. Vijay Kumar, this I think has been covered. Yes, a lot of repetitive yet common questions. Bootcamp free. Ajay, you can connect with the team. They are the best people to guide you. See discounts, scholarships, EMIs, how to avail best possible scenario to get as many discounts and coupons. They can guide you with that. But you'll also have to do a bit of hard work. That is, you'll have to give an entrance exam just for the team to know how capable you would be into the program. So that is your this thing. Again, I'm just launching the poll one funnel time. I can still see people who had missed out. Launching it one funnel time, a very short poll. Opt in yes if you want to know more about all these amenities and availabilities. It's perfectly all right if you had missed out earlier. Now is your final chance. And yeah, man, please feel free to register for this. and see your way around. Rabia, please connect with the team support at Scalar. They are the best people to guide you. Job goes longer, either DS or software engineer. Rabia, your skills matter. Do not go by security that this is some place I can just fit in and be a part of through and throughout time. No, if your skills are there, then you will be ahead. If you do not have the skills, then even an option that you feel you might be safe, you might not be. So Smita, data engineer is someone who makes the sophisticated architecture and decides pipelines and sits between the software developer and a data scientist or a machine learning architect. Prompt engineer is better, data analyst is better. Prompt engineer, Harish, is a very new concept that has come in ever so after ChatGPT. Data analyst gives you more idea about the facts and figures and uh, how you would want to dictate policies. But if you're more inclined towards AI, then you might want to look at prompt engineering as well. With that, we now conclude this session. Thank you everyone for joining in. I hope you had fun. Most importantly, I hope you got the answers we were looking for. For people who had said yes to the polls, you will be connected by the team in the next 48 hours and onwards. So please be ready with your set of questions. Please explore the internet to get as many questions as possible to make your let's say session rewardful, resourceful, and then take your decisions in the best way you would want to for your careers and for your preferences as well. Please feel free to connect with the alumni as well if you want to. You can let the counselors know; they'll be happy to walk you across. If you have a non-tech orientation, they can help you connect with people who had non-tech background and are killing it in the data science industry. So it's your call at the end of the day. Thank you, Aniket, for your kind words. Thank you everyone for joining in. Have a great week ahead. Stay safe. Cheers. Bye bye. Good night.